So if you feel hot for the sun, you can go. So about the DNS, the principle is that it's better to have names, symbolic names that can be understood by human beings in order to identify hosts and in particular hosts with also with services, and especially because these names are the input that you have to write as a human user for many applications, for example, web browsing. However, all equipment in internet works with IP addresses that are numbers, so we need some way to translate symbolic names into IP addresses. And this is the reason why the DNS, domain name system, was invented. It's a distributed database which is made of several name servers, and each server is responsible for a specific domain, and the applications can query this database using the local name servers in order to resolve the symbolic names. Moreover, this DNS also provides additional services like host aliasing, mail server aliasing, and load distribution that I have already described yesterday. So the structure is hierarchical. You have several the servers arranged in a tree architecture, and just to explain quickly, we can take an example. If we have to resolve the symbolic name www.google.com, the query first goes to the root name server, which is on the root of the tree, and it's responsible to find the specific server that is managing the domain.com. The domain.com is called top-level domain, and it is identified by the first letters on the right of the symbolic name. Once the domain the server domain.com, the name server domain.com is contacted, then in turn he will know where to find the name server of the domain google.com. Okay. Then the domain google.com is queried, and the domain google.com is able to perform the resolution of the address, because the domain google.com has a list of symbolic names and associated IP addresses belonging to the server of the domain google.com, as this list belonging to the domain google.com. So www is a specific symbolic name of that domain, so it corresponds to an IP address. The root name servers are a few and distributed around the world. And then we have also the local name server. The local name server is part of the DNS that is queried by the host and by the applications that need this name resolution. So each application will contact its local name server, and each host in the network has a local name server configured to contact to forward queries to the DNS. And then the local name server will contact the distributed database in order to find the requested information, and then it will return the requested information to the host that made the original request. And the authoritative name servers are also name servers that are responsible for a particular host name. So in the previous example, the authoritative name server is, in this case, the name server of the domain google.com, which holds information to resolve that specific name. So each name has its symbolic name has an authoritative name server with a specific line in a table that is referring to that name, where you can find the corresponding IP address. So this is the scheme of the query. The request comes from a host, and in the host there is an application that is asking for a name resolution. It goes to the local name server. The local name server then forwards the request to the DNS network. When it receives the response, then it will forward it back to the original host. And then we also seen yesterday the two modes to query the distributed database. In the iterative mode, the local name server that receives the request from the host starts by forwarding the request to the root DNS server, and the root DNS server answers back to the local DNS server directly with information regarding the name of the suitable top-level domain DNS server. Then it's the local DNS server again who queries the top-level domain DNS server. It replies with the name of the authoritative DNS server, and then again the local DNS server queries the authoritative DNS server. The other way, it's the recursive mode. Instead is a chain, so the local DNS server queries the root queries the top-level domain server, top-level domain server queries the authoritative name server, and the replies, responses follow the same path, okay, returning to the local domain server, same path as the request. Then we also mentioned that information can be cached in intermediate servers. Usually it's only the authoritative name server that can finally resolve the name. But when the authoritative name server replies back to other servers, intermediate servers may cache the requests. So when they receive another request for the same name, it's not necessary to go to the authoritative name server, but the replies may come from intermediate servers. Usually, is the local domain server that uses the cache and can reply immediately to the host for a request that have already been processed by the DNS distributed system. The authoritative name server associates also a time to live to each entry, and this time to live is used by a domain server, a name server that is caching the information in order to make it obsolete information after a certain time. So in this way, we can avoid that the cached replies are out of date compared to the original content of the database that is in the authoritative name server. So a non-authoritative server uses the time to live to decide a timeout of a cached information. And this is the resource record, which is the format in which all the tables of the DNS system stores data. So you have 4 fields: name, value, type, and time to live. The type decides the meaning of the other two fields, name and value. So the most frequent types are those listed here, but there are many more. There are more than 100. A is the type according to is the simplest type, the one that tells back the resolution, the final resolution of a specific on a specific symbolic name. So when the type is A, the name is the symbolic name, and the value is the IP address corresponding to that name. Then NS is used for the name servers, not for the mail servers, as I said yesterday. So in case the type is NS, the name is a domain of the DNS, and the value is the name of the name server that is responsible for that domain. For example, the domain elect.polyv.it, which is the domain of Politecnico, would be the name, and the value in case of NS is the name of the server that is hosting, that is playing as DNS server, in this case authoritative DNS server for the domain elect.polyv.it. So this is basically used to answer to queries for name servers. Then CNAME is to support the aliasing system. So when you have an alternative name that is given to a server with a specific symbolic name, or a host with a specific symbolic name, then you can ask the alternative name with the CNAME, or better. In this case, the name is the alternative name, the alias. For example, www.polyv.it is an alias. The value is the specific name of the host. In this case, it's a server that is, in this case, running this web service. And finally, NX is used for the resolution of mail domains. And so, in this case, the name is the name of the email domain, for example, polyv.it. And the value is the symbolic name of the name server that is responsible for the mail server that is responsible for that specific mail domain. Okay. This is a format of the DNS message. There is a DNS header that is represented there with the yellow boxes, where you have 12 bytes used to identify the message, and so the first field is for identification, allows to match request and reply pairs in the case when you have a name server that is receiving several different requests for different other, for example, local name servers. So you can identify the request and the reply. Then some flags that are used for different purposes. For example, the first is used to tell if the message is a request or a reply. The second is to tell if the information, the request accepts a non-authoritative answer or only authoritative answers. And the third is to set the mode of the polling of the database, iterative or recursive, as we have seen. And then each message can carry several questions and several answers in a single message. So the other fields are used to tell in the header to tell how many questions, how many answers, and how many additional information are contained in this specific message. So you have then a field for the questions in the data part, a certain number of questions, a certain number of answers. Then you have a part that is dedicated to records returned by services that are not authoritative. So it's for information that is retrieved by caching. And then some additional information that is used for special type of records. For example, when you are using the record MX and you are asking a question with of a MX type, in the additional information in the reply, the DNS automatically returns also the IP address of the mail server, not only the symbolic name, in order to avoid another query for the symbolic name. Practical case when a new company, for example, a startup, wants to have its own domain, so it wants to register a new domain. First of all, the company has to choose a domain, so a symbolic name for the domain, being sure that that symbolic name is available, not taken by somebody else. If a name is available, there are a list of available names, so that can be given to the domain of that company, a new domain. But this domain must be officially registered in the DNS system. So in order to do this, the startup has to go to an authority that is called DNS registrars. There are many registrars. There are many of them in the world. So you have to go to a registrar that is responsible for your geographical zone, and then ask for a registration of the new domain. So the company has to provide to the register the symbolic name of the domain and the IP address of the authoritative name server. Okay. So the authoritative name server must be provided by the company, or in some cases the registrars also provide hosting for authoritative name servers. Of course, this is usually you pay for this service. So once the registrar checks that the IP address exists and the symbolic name is free, then the new domain can be registered into the DNS server in a simple way. So the registrar will write in the top level domain server, for example, in this case .com, two new lines, two new enters, so two new records. One is of the type NX, and it has the name of the new domain and the symbolic name of the authoritative name server. The other one is of the A type, and it will have the symbolic name of the authoritative name server and its IP address. Sometimes, usually, companies ask for also new email domains, and then in this case the register will also add a record of type MX. It's clear this process. If you are a startupper, maybe you have already gone through this. Then another interesting way to use to exploit the DNS is the so-called content distribution network. So the CDN, the content distribution network, is used to distribute a large number of contents to several users, especially if these contents are quite heavy in terms of storage capacity required. For example, typical case, video. Usually the video in the past was offered by video servers, which are located in a specific place. But as the number of users of the video services increase, it's unpractical to have all the content concentrated in a few places in the world, because each time a user has to access this content, the content has to travel a long way through the network. So the solution is to use the content distribution network, which allows to distribute content into several databases dislocated or spread around a geographical area, so that a user, when he has to download content, will not download it from the centralized server, but it will download it from the closest distributed server, or from the closest content distribution network area. So the CDN is again a network of servers. Servers may be owned by the service provider or by the application provider, like for example Google, Netflix, Facebook. They all have their own content distribution networks. But if the service provider is not large enough, then it can also rent this infrastructure, content distribution network, from providers that are specialized in providing this service. For example, Akamai is the largest one, like Key, CDN, and others. So how it works? Assuming, let's look at an example. So the client of a video service, Bob, wants to download a specific movie, which is offered by a company that is called netcinema.com. So it goes to the website of netcinema.com, doing a search for that movie, and it finds an entry, so that netcinema.com has this content, and you can offer it to the user. But the user doesn't know exactly where the content is located, because this video provider has a content distribution network. So in this case, the video provider returns to the user, to the client of the user, a symbolic name that corresponds to that specific content. So netcinema.com/6y7b, so on and so forth. And the client of the user makes a DNS query to the local DNS server to resolve that specific name. The local DNS server, instead of starting to query the DNS database for that symbolic name, queries another DNS server that is the DNS server of netcinema. And it's again an authoritative name server, and it will return to the local name server not directly the IP address where to download the movie, but the symbolic name of the specific server of the DNS network that is storing that specific content. Because of course the server here, the DNS server of netcinema, knows exactly where all the contents are distributed in the content distribution network. So in this case, the name is kingcdn.com/net6 and so on and so forth. The content distribution network in this case, we assume that it is provided by another company, so a specific content distribution network provider. So now the local name server of the host can query the database, the DNS database. Finally, it will arrive to the authoritative DNS server of kingcdn, and here the final resolution can be done. And so at the end, the client of the user will receive the specific IP address, and then using that IP address, the download